Hey everyone, and welcome. Ever just stop and wonder how our digital world moves so incredibly fast? I mean, how does it juggle billions, literally billions of pieces of information and find the exact thing you need in like the blink of an eye? Well, today, we're going to pull back the curtain on the secret architecture that makes it all happen.
Seriously, think about this for a second. You're scrolling through your photo gallery, right? And thousands of your pictures just load. Seamless. You type in a friend's name and bam, a photo from 3 years ago pops right up. Is that magic?
Nope, not even close. The secret is just an incredibly clever system of organization. Think of it as the difference between a perfectly indexed library and a giant, messy pile of books on the floor. And this organization has a name.
Okay, let's dive right in. We're talking about something that is fundamental to all software, and it's called data structures. You can think of these as the invisible blueprints engineers use to build the fast, responsive apps that we all use every single day.
So, what are they really? Well, here's the textbook definition. A data structure is simply a specific way to organize and store data. But the key word here is efficiently. The whole goal is to be able to access and use that data as quickly as possible. You know, without that efficiency, your phone would take minutes, not milliseconds, to find that photo. And this is where it gets really cool. It all breaks down into two main types. On one hand, you have your basic bricks. These are the primitive types, like a single number or just one letter. But then you take those simple bricks and you use them to construct these huge, complex buildings. And those are the composite types, things like arrays and trees that we're about to explore.
All right, so first up, let's look at the most straightforward way to organize anything. Just putting it in a specific order, one thing right after another. The most fundamental of these is the array. The best way to think of it is like a bookshelf, where every single spot is numbered. You can instantly grab the book from slot number 5 because you know exactly where to go. It's simple, it's direct, and it's super fast for grabbing an item if you know its position.
Next, we've got a really interesting kind of order with something called a stack. Now, the crucial rule to remember here is this: last in, first out, or LIFO. The very last thing you add is the very first thing you're allowed to take out.
And who doesn't love a good pancake analogy, right? This explains it perfectly. When you get a big stack of pancakes, you don't dig down to the bottom to get the first one they made. Of course not. You take the fresh, hot one right off the top. That's a stack in action. Actually, your browser's back button, it works just like this too.
Okay, so let's completely flip that idea on its head. Now we've got a queue. And a queue follows the exact opposite rule. First in, first out, FIFO. This one is all about fairness.
The perfect analogy here is just waiting in line. We've all been there. If you're the first person to line up for coffee, you're the first person who gets to order. It's that simple. And computers use queues for everything, from managing print jobs to handling requests on a network, just to make sure tasks are handled in the order they showed up. But, data isn't always in a nice, neat, simple line. Sometimes, the most important thing isn't the order, but the relationship between different pieces of data. And this is where our blueprints start to get way more interesting.
Okay, take a look at this. What you're seeing here is a visual of what we call a tree structure. You can see there's a single point at the top, and then everything else just branches out from there. It immediately makes you think of a hierarchy, right?
So the big takeaway here is that a tree isn't a list. It's a hierarchy. You have one root at the very top, which has children. And then those children can have their own children. Your company's org chart, that's a tree. Your computer's file system with all its folders and subfolders, that's a tree too.
And trees are incredibly versatile. They're not a one-size-fits-all kind of deal. Engineers have created all these specialized versions for specific jobs. For instance, a binary search tree is built from the ground up to find information incredibly fast, kind of like looking up a word in a dictionary. A heap is designed to always keep the most important item right at the top, which is perfect for something like a priority to-do list.
But what if the relationships aren't a neat top-down hierarchy? What if everything can connect to everything else in a big, messy web? For that, you need a graph. Think about a social network, right? You are a node and your friendships are the edges connecting you to other nodes. Google Maps is another perfect example. It uses graphs to represent cities and all the roads connecting them. And finally, we've arrived at the secret weapon. For those near-instant lookups, you have the hash table. Okay, think of it like a coat check at a fancy party. You hand over your coat, that's your data, and they give you a unique ticket number, that's your hash. When you want your coat back, you just show them the ticket.
You don't have to search through every single coat. That ticket number tells them exactly where yours is, instantly. And that is how your phone finds one photo out of thousands so unbelievably fast.
So, okay, we've looked at stacks and queues and trees and graphs, but why does any of this actually matter to you if you're not a programmer? Well, because the choice of which blueprint to use has a direct, and I mean direct impact on your digital life. For a software engineer, this is it. This is one of the most critical decisions they have to make, right at the beginning of a project. Choosing the right data structure can literally be the difference between an app that people love and a total failure.
When they choose the right blueprint, that's when your social media feed loads instantly. Your search results appear in a flash. The entire app just feels snappy, responsive, delightful to use. Everything just works.
But if they choose the wrong one, oh, and we've all felt this pain, that's when you get that spinning wheel of death. You get slow loading times and an app that just feels clunky and incredibly frustrating. It's the invisible architecture that completely determines the quality of your experience.
And that brings us to the future. You see, these structures were designed for the problems of their time. But as we generate these absolutely unimaginable amounts of data for things like artificial intelligence, you have to wonder, are these blueprints enough? Or will this next generation of technology force us to invent entirely new ways to organize information?